Okay, good morning, my dear students. Today we do some question from class 10, Readmore Opt.Maths, 7th Operator Edition, Unit 5, Trigonometry, Exercise 1, page 175. Continue, question number 4. In 4, prove that on A 1 minus sin P was upon cos 2a. This is equal to sec 2a minus tan 2a. Now its solution here LHS left hand side equal to 1 minus sin 2a 1 upon cos 2a. This equal to 1 upon cos 2a minus sin 2a upon cos 2a, breaking it into two parts. 1 by cos, that is sec, so 1 by cos 2a, sec 2a, minus sin by cos, that is tan, so sin 2a upon cos 2a, tan 2a, which is the right hand side RHS. So it is proved. Now on B we have sin cos 2a upon 1 plus sin 2a, cos 2a upon 1 plus sin 2a. This equals to 1 minus tan a 1 upon 1 plus tan a. Now its solution here RHS equal to 1 minus tan a whole upon 1 plus tan a. Now this equal to 1 minus tan a, that is sin a upon cos a. Change into sin cos whole upon 1 plus tan a, that is sin a upon cos a. Now taking LCM on numerator and denominator both, we can write cos a minus sin a whole upon cos a. Similarly, taking the LCM on the denominator, we can write cos a plus sin a whole upon cos a. This equal to this denominator cos a cancel out, remaining cos a minus sin a whole upon cos a plus sin a. Now this multiplied by, to get cos 2a, we need its conjugate of numerator, so this both multiplied by cos a plus sin a term. Cos a plus sin a upon cos a plus sin a, because on the other just upper part is cos 2a, so to get cos 2a we need cos square a minus sin square a. Now it becomes cos a minus sin a, cos a plus sin a minus b, a plus b, it makes a square minus b square, so we can write cos square a minus sin square a, and downside cos a plus sin a, cos a plus sin a plus b, a plus b, a plus b was the square form, so cos a plus sin a was the square. Now continue. This equal to cos square a minus sin square, that is cos 2a whole upon cos a plus sin a was the square, that is cos square a plus sin square a plus 2 sin a cos a. A plus b whole square, a square plus b square plus 2ab. Now this is equal to cos 2a whole upon cos square a plus sin square a. Its value is 1 plus 2 sin a cos a, that is sin 2a, which is the LHS. It is proved. Now next part on C we have 1 plus cos 2a whole upon sin 2a. 1 plus cos 2a whole upon sin 2a. This equal to cot a. Now we solve some. Here LHS equal to 1 plus cos 2a whole upon sin 2a. Now either 1 of cos 2a, 1 plus cos 2a to cos square a minus 1 whole upon sin 2a to sin a cos a. 1 minus 1 cancel out, remaining 2 cos square a upon 2 sin a cos a. 2 to cancel out, 2 to cancel out, square and cos a cancel out, remaining cos a upon sin a, that is cot a, which is the RHS. So it is proved. Now on D we have 1 plus sec 2a whole upon tan 2a. 1 plus sec 2a whole upon tan 2a. This equals to cot a. Now you solve some. Here left hand side LHS equal to 1 plus sec 2a whole upon tan 2a. Now convert this into sine cos form. 1 plus sec 2a, that is 1 by cos 2a whole upon tan 2a, that is sin 2a upon cos 2a, turning into sine cos. Now taking LCM on the upper part, it becomes cos 2a plus 1 whole by cos 2a whole upon sin 2a upon cos 2a. Now cos 2a cancel out, remaining cos 2a plus 1 whole upon sin 2a. Now this equal to cos 2a, that is 2 cos square a minus 1, then plus 1 plus 2a, 2 cos square a minus 1 using formula upon sin 2a to sin a cos a. Minus 1 plus 1 cancel out, remaining 2 cos square a upon 2 sin a cos a. 2 to cancel out, square and cos a cancel out, remaining cos a upon sin a cos by sin, that is cot. So cos a by sin a cot a. This is the RHS. So it is proved. Now for A, on A we have t minus tan a, cot a minus tan a whole upon cot a plus tan a. This equals to cos 2a. Now its solution. Here cot A minus tan A LHS equal to cot A minus tan A whole by cot A plus tan A. Now cot change into tan, cot A, that is 1 by tan A minus tan A whole upon cot A 1 by tan A plus tan A. Now taking LCM on upper part and lower part, we get upper part 1 minus tan A whole upon tan A whole upon lower part 1 plus 1 minus tan square A, tan A into tan A, tan square A. Similarly downside 1 plus tan A into tan A, tan square A whole upon tan A. Now denominator tan A cancel out, remaining 1 minus tan square A whole upon 1 plus tan square A. This is the formula of cos 2A in terms of tan A, which is the RHS root. Now next part, yeah. On F we have cosec 2A plus cos 2A, cosec 2A plus cot 2A equal to cot A. Well, that's equal to cosec 2A plus cot 2A. Now convert into sine cos, cosec 2A 1 upon sine 2A cot 2A, that is cos 2A upon sine 2A. Now taking LCM, 1 plus cos 2A whole upon sine 2A, 1 plus formula of cos 2A, that is 2 cos square A minus 1 whole upon sine 2A. So this 1 minus 1 cancel out, remaining 2 cos square A whole upon sine 2A, that is 2 sine A cos A. To cancel out, e square and cos A cancel out, remaining cos A upon sine A, cos by sine, that is cot. So cos A by sine A, cot A, which is the RHS. So it is proved. Now G. On G we have sin 2A plus sin A, sin 2A plus sin A, 1 upon 1 plus cos A plus cos 2A, this equal to tan A. Now its solution, here LHS equal to sin 2A plus sin A 1 upon 1 plus cos A plus cos 2A. This equal to sin 2A to sin A cos A plus sin A 1 upon 1 plus cos A plus cos 2A, that is 2 cos square A minus 1 by using formula. Now upper part sin A is common over there, remaining 2 cos A plus 1. Here sin A common, remaining 2 cos A plus 1. Downside 1 minus 1 cancel out. Here taking cos A common, remaining 1 plus 2 cos A. This equal to 2 cos A plus 1, 1 plus cos 2A, that is same. This cancel out, remaining sin A by cos A, that is tan A, equal to RHS root. Now on else, we have 2 sine 2a plus sine 4a, 2 sine 2a plus sine 4a whole upon 2 sine 2a minus sine 4a. This equal to cot square a. Now a solution. Here this equal to 2 sine 2a plus sine 4a whole upon 2 sine 2a minus sine 4a. Now this equal to 2 sine 2a plus sine 4a. This is sine 4a. Sine 4a equal to sine 2 times of 2a. So it becomes sine 2a pattern. So here a is 2a. So 2 sine 2a dot cos 2a. So sine 4a equal to 2 sine 2a cos 2a whole upon 2 sine 2a minus again sine 4a, that is 2 sine 2a cos 2a, because sine 2 theta equal to 2 sine theta cos theta by using this formula. Then 2 sine 2a common over here, taking 2 sine 2a common, remaining 1 plus cos 2a whole upon downside 2 sine 2a common, remaining 1 minus cos 2a. Now this equals to 2 sine 2a cancel out, 1 plus cos 2a whole upon 1 minus cos 2a. 1 plus cos 2a, that is 2 cos square a minus 1 upon 1 minus cos 2a, that is 1 minus 2 sine square a. This equal to 1 minus 1 cancel out, 2 cos square a upon 1 minus into 1 minus 1 minus into minus plus 2 sine square a. Now this equal to 2 cos square a upon 1 minus 1 cancel out, remaining 2 sine square a. To cancel out cos square a upon sine square a, that is cot square a, which is RHS root. Now next question, I. On I we have 1 plus sine 2a minus cos 2a whole upon 1 plus sine 2a minus cos 2a whole upon 1 plus sine 2a plus cos 2a. This equal to tan a. Now a solution. Here LHS equal to 1 plus sine 2a minus cos 2a whole upon 1 plus sine 2a plus cos 2a. Now this equal to 1 plus sine 2a minus cos 2a, that is 1 minus 2 sine square a whole upon 1 plus sine 2a plus cos 2a, that is 2 cos square a minus 1. This equal to 1 plus sine 2a minus 1 minus minus plus 2 sine square a all upon 1 plus sine 2a 1 minus 1 cancel out, remaining sine 2a plus 2 cos square a 1 minus 1 cancel out, remaining sine 2a plus 2 sine square a all upon sine 2a plus 2 cos square a. Now you know for sine 2a 2 sine a cos a plus 2 sine square a all upon 2 sine a cos a plus 2 cos square a. Now taking common 2 sine a common, remaining cos a plus sine a all upon downside 2 cos a common, remaining sine a plus cos a. Sine a plus cos a plus sine a cancel out, 2 to cancel out, remaining sine a by cos a, sine a by cos a, that is tan a, which is RHS root. Now J on J we have sine a minus root over 1 plus sine 2a sine a minus root over 1 plus sine 2a whole upon cos a minus root over 1 plus sine 2a. This equal to cot a. Now solution here, LHS equal to sine a minus root over 1 plus sine 2a all upon cos a minus root over 1 plus sine 2a. Now this equal to sine a minus root over 1. Instead of 1 we can put cos square a plus sine square a plus sine 2a, that is 2 sine a cos a all upon cos a minus root over 1. Again, instead of 1 we can put cos square a plus sine square a plus sine 2a 2 sine a cos a. We know that cos square theta plus sine square theta equal to 1 by using this identity property. Now this equal to sine a minus root over a square plus b square plus 2ab. It makes a plus b whole square. So cos a plus sine a whole square all upon downside cos a minus similarly a square plus b square plus 2ab, a plus b whole square. So cos a plus sine a whole square. Now this equal to sine a minus square and square root cancel out, remaining cos a plus sine a all upon cos a minus cos a plus sine a. Now this equal to sine a minus cos a minus into plus minus sine a all upon cos a minus into plus minus sine a, remaining sine a minus sine a cancel out, remaining minus cos a Cos A minus cos A, cancel out, remaining minus sin A. Minus minus cancel out, remains cos A upon sin A, cos by sin, that is for A, which is RHS root. Now K on K we have now page number 176. Next page, 1 plus tan phi dot tan phi equals to sec phi. Now the solution here LHS equal to 1 plus tan phi dot tan phi. Now this equal to 1 plus tan phi 2 tan phi whole upon 1 minus tan square phi dot tan phi. Using formula of tan 2 theta equal to 2 tan theta upon 1 minus tan square theta. Here tan phi equal to tan 2 times of 2a. So theta is here 2a. So to tan phi upon 1 minus tan square phi. Now taking LCM, 1 minus tan square phi, 1 minus tan square phi 1 ja, 1 minus tan square phi plus 2 tan phi into tan phi, 2 tan square phi minus tan square phi plus 2 tan square phi, remaining 1 plus tan square phi whole upon 1 minus tan square phi. This equal to 1 whole upon 1 minus tan square phi upon 1 plus tan square phi. Now this equal to 1 minus tan square theta upon 1 plus tan square theta. That is the pattern of cos 2 theta. So this equal to cos 2 times of 3 equal to 1 by cos 2 to the 4a, 1 by cos, that is sec 4a equal to RHS group. Now next question, young. Now on L here, plus A minus sin A whole upon cos A plus sin A is equal to sec 2A minus tan 2A. Now its solution here LHS equal to cos A minus sin A whole upon cos A plus sin A. Now this equal to cos A minus sin A whole by cos A plus sin A. On the right side, sec 2A, that is 1 by cos 2A, tan 2A, that is 1 by sin 2A by cos 2A. On the both denominator is cos 2A. To get cos 2A, we need cos square A minus sin square. So multiply by numerator. cos A minus sin A upon cos A minus sin A to get cos 2A in the denominator. Cos A plus sin A, cos A minus sin A. It makes cos square A minus sin square A, because A plus B, A minus B equal to A square minus B square. Upper part cos A minus sin A, cos A minus sin A, that is cos A minus sin A whole square. Now this is A minus B whole square form using formula A square plus B square minus 2AB whole upon cos square A minus sin square A, that is cos 2A. Now cos square A plus sin square, its value is 1 minus 2 sin A cos A, that is sin 2A whole upon cos 2A. Now breaking this, 1 upon cos 2A minus sin 2A upon cos 2A. 1 by cos, that is sec 2A minus sin 2A upon cos 2A tan 2A, which is the RHS. So it is proved. Now on M we have sin 4A upon cos 2A, sin 4A upon cos 2A, which is multiplied by 1 minus cos 2A all upon 1 minus cos 4A. This equal to tan A. Now its solution. Here LHS equal to sin 4A upon cos 2A into 1 minus cos 2A 1 upon 1 minus cos 4A. Now this equal to sin 4A, that is 2 sin 2A cos 2A whole upon cos 2A into 1 minus cos 2A, that is 2 sin square A upon 1 minus cos 4A, that is 2 sin square 2A. Using the formula 1 minus cos 2 theta equal to 2 sin square theta and sin 2 theta equal to 2 sin theta cos theta. Then this equal to cos 2A cancel out, 2 cancel out, remaining sin 2A cancel out, remaining 2 sin square A, 2 sin square A upon sin 2A. Here sin square 2A, here sin 2A cancel out, remaining sin 2A. This is equal to 2 sin square A upon sin 2A, that is 2 sin A cos A. 2 cancel out, square and sin A cancel out, remaining sin A upon cos A, that is tan A, which is RHS proved. Now next number M. On M we have on N cot 2A plus tan A, cot 2A plus tan A equal to cosec 2A. Now the solution here LHS equal to cot 2a plus tan a. Now this equal to cot 2a, that is 1 upon tan 2a plus tan a. This equal to 1 upon tan 2a, its formula is 2 tan a upon 1 minus tan square a plus tan a is equal to 1 minus tan square a upon 2 tan a plus tan a. Now taking LCM, 1 minus tan square a plus 2 tan a into tan a, 2 tan square a all upon 2 tan a. Now minus tan square plus 2 tan square, remaining 1 plus tan square a all upon 2 tan a. Now this equals to 1 whole upon 2 tan a upon 1 plus tan square a. We know 1 by 2 tan a upon 1 plus tan square. This is formula of sine 2a in terms of tan a. So 1 by sine 2a, that is cosec 2a, which is the RHS root. Now next question. O. On O we have cos cube a plus sine cube a, cos cube a plus sine cube a all upon cos a plus sine a. This equals to 1 by 2 times 2 minus sine 2a. Now solution. Solution here. Different side LHS equal to cos cube a plus sine cube a whole upon cos a plus sine a. This is the form of cos cube a plus sine cube a. Equivalent making form using formula cos a plus sine a plus b a square cos square a plus b square sine square a minus ab cos a sine a whole upon cos a plus sine a. Using the formula of a cube plus b cube equal to a square a plus b a square plus b square minus ab by using this formula. Now this equal to cos a plus sine a cancel out, remaining cos square a plus sine square a 1 minus cos a sine a, that is we can write sine a cos a. Now this equal to this equal to 1 minus sine a cos a, we can put 1 by 2 times 2 sine a cos a multiply by 2 upon 2. Now this equal to taking LCM 2. Now 2 ones are 2 minus 2 sine a cos a. It becomes 1 by 2 2 minus 2 sine a cos a, that is sine 2a. This equal to RHS root. Now next question P. On P we have 1 plus sine 2a 1 upon 1 minus sine 2a, this equal to 1 plus 10a 1 upon 1 minus 10a, it's whole square. Now P is solution here. RHS equal to 1 plus 10a all by 1 minus 10a is whole square. This is equal to changing into sine plus 1 plus 10a, that is sine a upon cos a all upon 1 minus 10a, that is sine a by cos a, its whole square. Now taking LCM with bracket, it becomes cos a plus sine a all upon cos a all by cos a minus sine a all by cos a its whole square. Now this equal to denominator cos a cancel out, or you can write cos a plus sine a whole square upon cos a whole square, that is cos square a whole upon cos a minus sine a whole square whole upon cos a whole square, that is cos square a. Cos square a cancel out, a plus b whole square, we can write a square plus b square plus 2ab to sine a cos a. Similarly, cos a minus sine a whole square, that is cos square a plus sine square a minus 2 sine a cos a, because a plus minus b whole square equal to a square plus b square plus minus 2ab by using this formula. Now cos square plus sine square, its value is 1, so 2 sine a cos a, that is sine 2a. Similarly 1 minus 2 sine a cos a, sine 2a. This is the LHS. So proved. Now next question Q. On Q here cosec 2a plus cot 4a, cosec 2a plus cot 4a equal to cot a minus cosec 4a, cot a minus cosec 4a. Now its solution here. LHS equal to cosec 4a plus cot 4a, cosec 2a, cosec 2a plus cot 4a, cosec 2a, that is 1 upon sine 2a, cot 4a, that is cos 4a upon sine 4a. Now this equal to 1 by sine 3 plus cos 4a, that is 2 cos square 2a minus 1 sine 4a, that is 2 sine 2a dot cos 2a by the formula of cos 2 theta equal to 2 cos square theta minus 1 and sine 2 theta. Sine 2 theta equal to 2 sine theta cos theta. Now taking LCM, 2 sine 2a dot cos 2a. Sine 2a is into same, remaining 2 cos 2a into 1, 2 cos 2a plus 2 cos square 2a minus 1. Here 2 cos 2a common, taking 2 cos 2a common, remaining 1 plus cos 2a minus 1 whole upon 2 sine 2a cos 2a. Now 2 cos 2a dot 1 plus cos 2a whole upon 2 sine 2a cos 2a, breaking this first part upon denominator, minus second part 1 upon 2 sine 2a cos 2a. 2 sine 2a dot cos 2a. Now this equals to 2 cos 2a, cancel out, remaining 1 plus cos 2a upon sine 2a. 1 plus cos 2a upon sine 2a minus 1 by 2 sine 2a cos 2a, that is sine 4a. Now we combine this sine 4a, that is 2 sine 2a cos 2a. 1 plus cos 2a, 1 plus cos 2a, that is 2 cos square a minus 1 cos 2a, 2 cos square a minus 1. 1 upon sine 2a, 2 sine a cos a, minus 1 by sine 4a, that is cosec 4a, 1 by sine cosec. Now this equals to 1 minus 1 cancel out, 2 cos a, 2 cos a cancel out, remaining cos a by sine a. Cos a by sine a minus cosec 4a. We know cos by sine, that is cot, so cos a by sine a cot a minus cosec 4a, this equal RHS rule. Now next question, R. R, we have 1 upon 10a, 1 upon 10a minus 1 upon 10 equals to 1 upon sine 3. Now in solution, here LHS equal to 1 upon 10a minus 1 by 10p. This equal to 1 by 10a minus 1 by 10p, that is 2 10a upon 1 minus 10 square, because 10 to theta equal to 2 10 theta upon 1 minus 10 square theta by this formula. This equal to 1 by 10a minus, it becomes reverse, 1 minus 10 square upon 2 10a, making reverse 1 minus 10 square a upon 2 10a. Now taking LCM, 10a to 10a, so LCM is 2 10a, this divided by this, remaining 2 into 1, 2, minus 1 minus 10 square a equal to 2 minus 1 minus minus plus 10 square a whole upon 2 10a. 2 minus 1, 1 plus 10 square a whole upon 2 10a. Now this equals to 1 by 2 tan A upon 1 plus tan square A. We know 2 tan A upon 1 plus tan square, that is sine 2A in terms of tan A. So this is equal to 1 by sine 2A. This is equal to RHS root. Okay students, this was for today. Have a nice study. Have a nice time. See you soon.